Welcome back, everybody, to The Deep Dive. We've got another really interesting one for you today. The title of our source material is The Final Boss. Can Humanity Beat the Universe? Now, before you grab your lightsabers or anything, we should probably clarify that this is not about some kind of big bad guy out there in space. It's actually about something way bigger than that.
Absolutely. This is about the very nature of the universe itself and the idea that everything from the smallest particle to those giant, what are they called, superclusters of galaxies, it's all at its core just energy.
And the source we're diving into today argues that mastering this energy, like really understanding it and controlling it, might actually be the key to humanity's survival in the very long run.
It's a pretty radical concept when you think about it.
Yeah, especially when you consider the scale, right? I mean, we're talking about the entire universe here.
Right. And the source kind of sets the stage for this by laying out this incredibly ambitious timeline. It starts with the Big Bang and goes all the way to, like, potential future energy technologies. It's a way of framing human history within this much larger story, this grand narrative of energy itself.
So I guess the best place to start is, well, the beginning, right?
Right.
The Big Bang.
Right.
It's almost impossible to even wrap our heads around just how massive that event was, isn't it?
Yeah, it really is, right? Like, to imagine all of the energy that makes up, well, everything, crammed into this infinitesimally small point.
Right.
And then, bam, it explodes outward. That's what set everything in motion, space, time, everything as we know it.
And then, what, like hundreds of thousands of years after the Big Bang, atoms start to form, right?
Yep. So the energy starts to cool down, stabilize, and form those first, like, building blocks of matter.
Right, right. Okay, so we go from this pure energy explosion to these, like, tiny particles. That's a pretty big leap, isn't it?
Oh, it's huge. It's almost like the universe taking its first baby steps towards complexity, you know? And then a couple 100 million years after that, stars begin to ignite.
Those giant fiery balls of, well, more energy, right?
Right. They basically become these massive fusion reactors, fusing hydrogen into helium, releasing just insane amounts of energy in the process.
And it's inside those stars where the heavier elements are forged, right?
Exactly.
The stuff that planets are made of, the stuff that eventually life is made of.
It's crazy to think about, isn't it? Like the carbon in our bodies, the oxygen we breathe, all of that stuff was created in the heart of a star billions of years ago.
It really makes you feel connected to, well, everything, doesn't it?
It does.
But we should probably get back to that timeline, huh?
Yeah, let's do that.
So our own planet, Earth, forms about, what was it, 4.6 billion years ago?
Got that, yeah.
And then the first single-celled organisms, like the very first life on Earth, pops up about 3.5 billion years ago.
That's right.
And then fast forward a few more billion years, and boom, here we are. Humans enter the scene, what, like 300,000 years ago?
A blink of an eye in cosmic terms.
Really puts things in perspective, doesn't it? And what's even more interesting is that we, as humans, seem to be the first species on Earth capable of not just understanding, but actually manipulating energy in a way that, like, no other species ever has.
I mean, you think about it, we went from discovering fire to harnessing electricity and even splitting the atom in a really short amount of time.
Yeah, it's amazing when you think about it like that. But there's a question the source brings up here. Are we limiting ourselves by the way we usually think about energy, like with all these different categories and labels?
Right. I mean, we've got gravity, electromagnetism, nuclear forces.
The source proposes this really interesting idea. What if these seemingly different forces are actually all just different expressions of the same underlying thing, energy?
Yeah. That's where things start to get really interesting. So, for example, the source suggests that gravity might be better understood as what they call energy inertia, right?
Okay, inertia, that's like an object's resistance to change in motion, right?
Exactly. And we know that gravity pulls things together. So what if gravity is just the massive inertia of all the energy in the universe holding everything together in this, like, cosmic dance?
That's a big concept.
It is.
I'm not sure I fully grasp it, but I think I get the general idea.
Yeah, it's definitely one of those things you got to kind of sit with for a bit.
It's like we've been looking at all these forces in isolation, you know?
Right, in their separate little boxes.
And maybe we've been missing the bigger picture. like how they all connect back to this fundamental energy.
Exactly. And it goes beyond just gravity, too. The source also talks about how electromagnetism, the force behind electricity and magnetism, could be understood as energy organizing itself into, positive and negative charges.
So it's not just about attraction or repulsion, but about energy creating these fundamental structures, these patterns.
Right. And then there are the nuclear forces, the incredibly strong forces that hold the nucleus of an atom together. What if those are just energy locked into, super tight interactions at the quantum level?
It's like energy finding all these different ways to express itself, isn't it?
Yeah, that's a great way to put it.
And even time. I mean, the source goes so far as to suggest that time itself might just be a measure of the rate at which energy interacts.
Yeah.
So the faster the energy is exchanging, the faster time seems to flow.
No, that's a head scratcher, right?
Definitely.
Yeah.
It almost makes you rethink everything you thought you knew about, well, reality itself.
And then there's quantum mechanics, which always seems so weird and counterintuitive.
Right.
Maybe it's just energy behaving in a statistical way at these incredibly small scales, kind of like a cosmic game of chance where probabilities are king.
So what's the takeaway for our listeners here?
No.
Why should we care if gravity is energy inertia or time is a measure of energy interaction?
Well, what's fascinating is that this whole unified energy perspective really challenges our traditional categories, our scientific boxes. It suggests that we might be missing a deeper understanding of the universe, an understanding that could open up all sorts of new possibilities.
New technologies, new ways of interacting with the world.
Absolutely.
So instead of seeing separate forces like gravity and electromagnetism, we should be looking for the underlying energy that's driving them all.
Exactly. It's like we've been studying the individual instruments in an orchestra without realizing that there is a conductor, a unified energy, guiding the whole symphony.
I like that analogy. Okay, so we've gone from the Big Bang to energy in disguise. Where do we go from here?
Well, the source takes us on this journey through what they call the technological ladder, the tools we've developed to harness and control energy. And it all started with something surprisingly simple: the wheel.
The wheel, huh? Seems pretty basic now.
It does, but it was a revolutionary invention. I mean,
Yeah.
It represented this fundamental breakthrough in our ability to transfer and manipulate mechanical energy.
It's true. It's
Yeah.
easy to take the wheel for granted, but it really did change everything, didn't it?
It revolutionized transportation, agriculture, all sorts of things. It allowed us to move heavier loads, travel farther, build bigger and more complex things. It was a crucial step in our journey to master energy.
Right, right. And then came the steam engine, right? Harnessing the power of heat to generate mechanical energy.
And that was the beginning of the Industrial Revolution.
Talk about a game changer. Suddenly we could power machines, factories, all sorts of things.
It led to unprecedented levels of production, economic growth. I mean, it really transformed society.
But then came an even more profound discovery: electricity.
Yeah, that was a whole new ballgame.
Suddenly we had this incredibly versatile, controllable form of energy.
We could use it to power lights, motors, communication devices. I mean, it literally illuminated the world.
It really did usher in the modern era,
And then, in the 20th century, we entered the nuclear age.
unlocking the power within the atom itself.
Yeah, that's where Einstein's famous equation, E=mc², comes in. It basically showed us the mind-boggling amount of energy contained within even the tiniest bits of matter.
And nuclear fission, splitting those atoms, gave us a source of power unlike anything we had ever seen.
Right. But it also came with a stark warning: the potential for destruction on a scale we had never imagined before.
A reminder that with great power comes great responsibility.
Yeah.
So the source goes on to list all these other key technologies, right?
Right.
Computers, the space age, the internet, all the ways we're applying quantum mechanics, solar energy, AI, machine learning. I mean, it's a pretty impressive list.
And the pace of these discoveries is just accelerating, isn't it? In just a few centuries, we went from burning wood for warmth to manipulating atoms and exploring the universe. It's mind-blowing.
Which brings us to a really important question. Where do we go from here?
And that's where the source takes kind of a darker turn, They suggest that we might be facing a challenge that's even bigger than just coming up with the next technological innovation. They're talking about the universe itself, like it might be working against us in a way.
Okay, now that's a bit ominous. What do you mean by the universe working against us?
Well, we've known for a while now that the universe is expanding, right? But recent discoveries have actually shown that it's not just expanding, it's accelerating.
Accelerating. So it's not just galaxies moving apart. It's like the space between them is actually growing at an increasing rate.
Exactly. And this acceleration, the source says, is attributed to something called dark energy.
Dark energy. I've heard the term, but I'm not sure I really understand what it is.
It's still kind of a mystery, to be honest, even to scientists. But the way I like to think about it is like it's this invisible force that's pushing everything apart. It's stretching the very fabric of space-time.
So instead of slowing down over time, like you might expect after a Big Bang, the expansion is actually speeding up.
That's the current understanding, yeah. And the rate of this expansion is measured by something called the Hubble constant.
Okay, so the Hubble constant tells us how fast the universe is expanding. But how does that affect us here on Earth?
Well, the source suggests that this accelerating expansion could have some pretty serious consequences for life in the universe. I mean, think about it. If the universe keeps expanding at this rate, eventually everything will be so far apart that galaxies will become like isolated islands in this vast empty sea.
And if we're all that spread out, wouldn't it make it incredibly difficult to access resources, to connect with other civilizations, even to explore the cosmos?
Exactly. The source actually suggests that this expansion could eventually lead to a kind of cosmic loneliness, where civilizations are stranded in their own little pockets of the universe, unable to interact or share knowledge or, well, anything.
That's a pretty bleak picture.
It is. Like we're on this cosmic treadmill, you know? Constantly running just to stay in the same place while the universe keeps pulling us apart.
So the source is saying that instead of focusing on all these, earthly conflicts, all this squabbling over limited resources, we need to wake up to this much bigger picture.
This existential threat, yeah. This cosmic expansion that could ultimately isolate us from the rest of the universe.
So what can we do about it? I mean, how do you fight back against something as fundamental as the expansion of the universe? And that's where this idea of the Kardashev scale comes in, right?
Yep, you got it. The Kardashev scale was proposed by a Russian astrophysicist, Nikolai Kardashev, back in the 1960s. He basically imagined this scale that ranks civilizations based on their energy consumption and technological advancement.
So it's like a measure of how advanced a civilization is.
Exactly. And he proposed three main levels: Type I, Type 2, and Type 3, each representing a significant leap in energy mastery.
Let's break those down a bit. What would a Type I civilization be like?
A Type I civilization would be able to harness all the energy resources of their home planet. Imagine being able to tap into the full power of our sun, wind, tides, geothermal energy, everything.
Wow. So complete energy independence. No more reliance on fossil fuels or limited resources.
Exactly. A Type I civilization would have essentially achieved planetary energy mastery.
That's pretty impressive. Okay, what about Type 2?
A Type 2 civilization takes things to a whole new level. They can control the energy output of an entire star.
Hold on. An entire star. Like harnessing the power of our sun.
The whole thing, yep. There's this theoretical concept called a Dyson sphere, which is this mega structure that would basically surround a star and capture its entire energy output.
So instead of solar panels on our rooftops, we're talking about a giant sphere encapsulating the sun.
It's a pretty mind-blowing idea. Of course, actually building something like that would require technologies far beyond anything we have today. But, I mean, that's the point of the Kardashev scale, right? It's about imagining the possibilities, pushing the boundaries of what we think is achievable.
Okay, it's starting to get the picture. So Type I, planetary energy mastery. Type 2, stellar energy mastery. And then there's Type 3. That's where things get really crazy, right?
Yeah. Type 3 is galactic-level civilization. They'd be able to control energy on a galactic scale, potentially harnessing the power of black holes, manipulating space-time, maybe even influencing the evolution of galaxies themselves.
Okay, now we're talking about, like, godlike powers. But the source seems to be suggesting that these aren't just fantasies. They're goals we should actually be striving for.
The source is definitely saying that if we want to survive in the long run, we need to start thinking bigger, bolder, much more ambitiously.
So where do we stand on this scale right now? Are we even close to being a Type I civilization?
Well, most estimates, based on our current energy consumption and technological capabilities, place us somewhere around a 0.7 on the Kardashev scale.
0.7. Doesn't sound like we've come very far.
It means we're still heavily reliant on fossil fuels, we haven't really mastered renewable energy sources, and we still struggle with even basic things like global cooperation and resource management.
So we've got a long way to go.
Yeah.
But the source is saying we need to climb this Kardashev ladder pretty quickly if we want to, survive all these cosmic challenges.
The source definitely emphasizes the urgency of the situation. They're saying the longer we remain this low-level civilization, the more vulnerable we are to these forces of the universe, forces we don't fully understand and can't control.
So how do we get from a point 0.7 to a type I, or even a type 2 civilization? What kind of, I don't know, radical solutions does the source propose?
Well, they outline some truly mind-bending possibilities, ideas that are, right at the edge of scientific understanding, but they could hold the key to our future, our cosmic future, if you will.
Okay, hit me with some of these mind-blowing ideas. What are we talking about here?
One of the ideas is vacuum energy extraction. Ever heard of that?
Vacuum energy, isn't that like pulling energy out of thin air?
Essentially, yeah. It's based on the idea that even seemingly empty space is actually teeming with what they call quantum fluctuations. These virtual particles are popping in and out of existence all the time, and if we could figure out how to tap into that energy, it would be an almost limitless source of power.
Isn't that supposed to be impossible, though? Like breaking the laws of physics?
It's definitely pushing the boundaries of what we currently understand. But the source argues that we shouldn't dismiss ideas just because they sound strange or counterintuitive, you know?
Yeah.
What seemed impossible to one generation often becomes reality for the next.
So keep an open mind, explore all possibilities, no matter how out there they might seem.
Exactly. Another radical idea is dark energy manipulation, that mysterious force that's driving the expansion of the universe. What if we could somehow learn to control it, to reverse it, or even harness it for our own purposes?
Now, that sounds incredibly ambitious. I mean, we can barely even detect dark energy, let alone control it.
It's true. But think about it. If we could figure it out, it would be a total game changer. Imagine being able to manipulate the very fabric of space-time, counteracting the expansion of the universe. Maybe even creating wormholes for faster-than-light travel.
That's next-level stuff.
It is. The source also talks about creating artificial gravity wells. These would basically be regions of space where gravity is stronger, pulling things together even as the universe expands around them.
So instead of being pulled apart by the expansion, we could create our own little pockets of stability.
Exactly. Pretty wild, huh?
Definitely. Okay, so we've got vacuum energy extraction, dark energy manipulation, and artificial gravity wells. Anything else on this list of radical solutions?
Oh, there are a few more. They mentioned something called zero-point energy, which is another theoretical source of energy from the quantum vacuum. And then there's horizon harvesting, which involves capturing energy from black holes right at their event horizons.
Wow. Black holes, that's pretty intense.
It is. All of these ideas are incredibly ambitious. It's hard to even imagine what a civilization capable of these things would look like.
It really stretches the imagination, doesn't it?
It does. But that's part of what I love about this deep dive. It forces us to think beyond our current limitations, to really imagine what might be possible if we can overcome these challenges ahead of us.
It's a reminder that the universe is full of mysteries, and that we humans, well, we're just beginning to scratch the surface of what we might be capable of. It really does feel like we're at this crossroads, in human history. Like we can choose to be, overwhelmed by all these challenges, or we can choose to rise to meet them and maybe become something truly extraordinary in the process.
That's a great way to put it, yeah. The source definitely seems to think that humanity has this incredible potential, but we need a serious shift in perspective, in our priorities, even in how we see ourselves and our place in the universe.
It all comes back to this idea that everything is energy, right? Like it's almost like a mantra for them.
It's like they're trying to get us to look at the universe, at reality itself, in a whole new way.
It's almost a spiritual idea, but they ground it in science and technology, which I find really interesting. Yeah, and that's what makes this perspective so powerful, I think. It kind of bridges the gap between the material world and the immaterial, between the scientific and the philosophical. If everything truly is energy, then mastering it isn't just about building bigger machines or harnessing more power. It's about understanding the very essence of reality.
And maybe even understanding ourselves better. I mean, if we are energy and everything around us is energy, then, well, the possibilities for connection and interaction could be limitless, right?
That's a pretty profound thought, and it's definitely something the source wants us to consider. They leave us with this final challenge, this question that really echoes throughout the whole deep dive.
Okay, I'm ready. What's the big question we should all be pondering?
If everything truly is energy, what does that mean for our understanding of ourselves, our place in the cosmos, and the future of our species?
Wow. That's a huge question, almost too big to even wrap your head around.
It is, but that's what makes it so compelling. It's a question that could inspire, like, a lifetime of exploration, discovery, growth.
Well, this deep dive has definitely given me a lot to think about. It's kind of shifted my perspective on everything, from the smallest atom to the vastness of the universe.
It's definitely challenged how we usually think about energy, technology, humanity's place in it all.
Who knows? Maybe one of our listeners out there will be inspired to, I don't know, unlock the secrets of energy and help guide us to a brighter future.
That would be incredible, wouldn't it? It's a good reminder that even when facing, like, the biggest challenges, that human spirit of exploration and innovation, that's one of our greatest strengths.
Well said. I think we've covered a ton of ground today, from the Big Bang to the Kardashev Scale, all these mind-blowing concepts in between. It's been quite a journey.
It has, and I have a feeling this is just the beginning of our exploration of these ideas. There's so much more to uncover, to understand.
Absolutely. And we'll be revisiting these topics in future deep dives as new discoveries are made, new theories come out.
We're living in a truly remarkable time, an era of just incredible scientific and technological advancement. It's exciting to think about what wonders are still waiting out there to be discovered.
That's the best part, right? The future is full of possibilities, and we can't wait to explore them with all of you. So until next time, keep looking up, keep asking questions, and keep that cosmic curiosity alive.
Couldn't have said it better myself. And remember, the universe is full of energy, and so are you. Never underestimate your potential to make a difference.
That's a perfect note to end on. Thanks for joining us on this incredible deep dive. We'll see you next time.